Figure 2.9, comparing integers using if statements, relational operators, and equality operators. In this program, we're going to simply compare two integer values entered by the user. Let's run the program first so that we can see it in action, then we'll take a look at the actual source code. So basically, the user is required to enter two integer values, and when they press enter, the program compares those two values and shows you, using the relational and equality operators, which comparisons evaluated to true. In this case, we found out that 10 is not equal to 20, 10 is less than 20, and 10 is less than or equal to 20. If I run the same program again, and this time I enter 20 followed by 10, I see that they're still not equal, but this time 20 is of course greater than 10, and 20 is greater than or equal to 10. And finally, if I run with a couple of identical values, you can see in this case that the two values are equal. The first value is less than or equal to the second, and the first value is greater than or equal to the second. Now, the other thing that we'll do at the end of this program is run it again and show you what happens if the user does not enter an integer value. So, as we mentioned in the first program, just about every program we do in this Live Lessons product is going to include the IOStream header file. And again, this is giving us access to the standard output capabilities and, as you'll see in this program, the standard input capabilities as well that allow the user to interact with the program at the command line. Now, in the first program, when we used the cout object, we did it by saying std : cout. And so it looked like this on line 16. However, I mentioned in that program that we were going to show you a way that you could write cout without having to say std : in front of it. And in fact, lines 6 through 8 are going to give us access to the names cout, cin, and endl, all from the C++ standard library. Now, everything in that library is wrapped in what we call a namespace. And a namespace is a way to help you uniquely identify names that are part of your program and various libraries, etc. Everything that's part of the C++ standard library is part of the so-called std namespace, and std stands for Standard C++ Library. So we're using in this program the standard library's cout object, we're using the standard library's cin object, and we're using the standard library's so-called endl stream manipulator. That's ENDL, not END1, and the endl stream manipulator is used with cout to insert a new line character into the output to move to the next line, and also to do what we call flushing the output buffer. We'll come back to that in a moment. So these are using statements, and each one of them is announcing to the rest of the code in this file that we are able to use that particular identifier from the standard namespace by its simple name, which is just cout, cin, or endl, respectively. So you can see here on line 16 we have cout, on line 20, on line 23, etc. Whereas if we did not have line 6, every single time we mentioned cout, we would have had to say std : cout. Now, there's another way that you can use the using statement as well. We could have said using namespace std. And in this case, what we're saying is everything from the standard namespace that's included in this file is allowed to be used by the program. And that obviates the need for lines 6 through 8 because cout, cin, and endl are all part of the standard namespace, and everything that we include from the IOStream header and the other standard library headers as well is also considered to be part of that same namespace. So in our C++ for Programmers book and in this live lesson, we'll typically show you using statements that announce each individual item we use from the standard libraries, and we do that as kind of a form of documentation to show you what we're using in the program. But there's also another benefit to doing it like lines 6 through 8 rather than line 10 that I just typed, and that benefit is that if you're including header files from other third-party libraries or your own libraries, it's conceivable that you could accidentally have something declared in those libraries that has the same names, and we don't want to run into what we call a naming collision if we can avoid it, and that's one of the purposes of namespaces. So for that purpose, we're going to typically try to bring in or allow use of as few names as possible in each program, and that's one way to help prevent naming collisions. So let's go ahead and take a look at our main program. For the first time, we're declaring variables that we can use to store data. In C++, every variable you declare must be specified with a data type before you use the variable. So in this case, we're saying that number 1 is an int, and an int represents an integer whole number value. And one thing that you need to keep in mind about integers in C++ is that depending on your hardware and your compiler, the number of bytes used to store an int may differ from system to system. On some systems it could be 2 bytes, on others it could be 4 bytes, on yet others it could be 8 bytes, and even beyond that as well. The C++ standard only specifies the relative sizes of int to the other integral numeric types like short and long, and we'll talk about those more as we proceed. But this is one of the reasons that even though C++ is considered to be a quote-unquote portable language, it's not necessarily the case that if you take a program from one system, move it to another system, and recompile it, that it's going to run exactly the same way on that other system. So when you build C++ programs, if you intend for them to run across multiple platforms, you'll need to thoroughly test those programs across the platforms, and you may even need to modify them to get them to work correctly. The other thing you should note about lines 13 and 14 and variables in general in C++ is that in just about all cases, variables are not initialized for you. And that means that these two variables, at least initially, have garbage data in them. So what that means is anytime you intend to use a variable, you need to give it a value before you use it. And the way we intend to use these two variables is to compare them in these if statements starting at line 19. So before we get to line 19, we need to make sure that we give these two variables values. And we do that starting at line 16, where we say enter two integers to compare. That's prompting the user to enter two integers. And when you do a cout statement, that does not end with either a new line character or with an endl stream manipulator, as we'll do down at line 20. If you follow a cout statement with a cin, these two streams, as they're called, are tied together such that when you do an output, before the input statement will execute, the output will be forced to happen. It will show up on the screen. Then the input statement will execute. So the prompt, enter two integers to compare, will appear. Then we will execute our cin statement. Now, cin is the standard input stream object. It allows you to read characters typed by the user at the keyboard. And when you say cin double greater than sign number 1, that is read as cin gives a value to the variable number 1. And this is the so-called stream extraction operator. It's saying extract an integer value into the variable number 1, and I know it's an integer value because number 1 was declared to be of type int. So cin is going to try to read an int into the variable number 1. Once it's finished with that, it will then try to read a value using the next stream insertion operator into the variable, stream extraction operator rather, into the variable number 2. And assuming that both of these inputs work correctly, then we'll have values for number 1 and number 2 that we can compare. And I'll run the program to show you what happens when we have invalid input. Now, in C++, the way that you compare numbers for equality is using the double equal sign operator. And this is one of the most common programming errors that new C and C++ programmers run into. They will accidentally type a single equal sign here, which is perfectly valid in C and C++ because every assignment expression, and that's the assignment operator now, has a value in C and C++. The value of the expression is whatever gets placed in the variable on the left side of the single equal sign. And basically in C++, if something is the value 0, it's considered to be false, and if it's non-zero, it's considered to be true. So this can be the source of many very difficult to find logic errors in C and C++. When you're doing comparisons, think of it as the double equals operator to help remind yourself to type two equal signs. The other thing is, whenever you have any kind of operator that is composed of multiple characters, you're not allowed to have spaces between them in C++. So here we're going to compare number 1 and number 2 to see if they're equal, and only if this is true will the statement at line 20 execute. Now, the if statement in C++ expects only one statement in its body, but wherever you have a single statement in C++, you can have a block of statements delimited by curly braces. So if I wanted to do multiple things as a result of number 1 and number 2 being equal, I can delimit the body in curly braces and put as many statements as I wish in between those braces. So let's go back to the way it was originally. So if these two numbers are equal, we're going to output using the stream insertion operator the value of the variable number 1, followed by the string double equals with spaces around it, followed by number 2, followed by the endl stream manipulator. And what that does is it inserts a new line character and quote-unquote flushes the output buffer, which makes that output appear on the screen immediately. And flushing the buffer is useful sometimes when you're writing to files to make sure that bytes make their way into a file, or when you're writing to a network connection to make sure bytes get sent across the network connection. The other operators that we're using in the next 5 if statements are the not equals operator, and exclamation point equals is a common way to represent not equals in C, C++, C#, Objective-C, Java, JavaScript, and other programming languages as well. Yet other programming languages use different symbols for that same operator. But in a lot of programming languages, this is your not equals operator. We also have less than and greater than, and then for the less than or equal to and greater than or equal to, it's the less than sign followed by an equals operator, or the greater than sign followed by an equals operator. And again, you are not allowed to have spaces in between the operators. Finally, we have our return 0 statement, which we mentioned in the first program is not necessary in C++. If you eliminate line 37 and the program reaches line 39 without encountering a return statement, C++ programs will automatically return 0 for you. So the compiler will basically insert that statement for you automatically. Now let's run this program one more time, and this time I just want to show you what happens if we enter invalid input. So let's say we type 1000 and hello as our two inputs. Only one of those is clearly an integer. And when I do that, I see 1000 for the first number, and I see this large negative value for the second number. That's the garbage value that happens to be stored in the variable number 2 at the point where I declare it and it gets allocated in memory. In C++, when a variable gets allocated in memory, that memory does not get initialized by default unless you specify otherwise. So here we're seeing the result of that, a garbage value. And basically what happened is when the program encountered the input into the variable number 2, it tried to read an integer. It encountered instead the string hello, couldn't convert that to a number, and simply failed in terms of inputting a value into number 2. And then the program just continued executing using whatever happened to be stored in the variable number 2 when it was first declared at line 14. And similarly, if I close this window and run the program one more time, let's type hello first and then a number, and in this case you see that we get garbage values on both sides, because the way cin works is if the first input fails, it doesn't even continue attempting to do the next input. There are some flags that get set in the so-called cin object that help it determine whether or not the stream is still considered to be valid. Once you have a failed input, it immediately is considered to be invalid, and the only way to do more input is to reset the stream. That's something that we cover in later lessons. So in this program, we introduced the concept of using statements. We showed you a little bit of input-output, and we showed you how to declare variables and use the relational and equality operators. And all of these are concepts that you'll see in most of your C++ programs. We'll now move on to the next lesson, where we'll start to introduce to you the concepts of object-oriented programming, and in particular how to create your own so-called classes.